Welcome to my channel. I am Ozan Atmar. This is my first robotic project video on YouTube. Please subscribe to my channel and push the like button if you find the video helpful. You can also write your suggestions and ideas in the comments. I'm going to show every step of my project: remote control assembly and programming, tanks assembly and programming, and finally testing it. Here is the wiring schematic of my remote control. The Arduino board is powered by 5 AA batteries. I connected the battery pack to Win and ground inputs. The nRF24 module is connected as it seems here. This is the joystick. The FreeSync software does not have my joystick in its library, but it has the same outputs as mine. I taped the remote control elements on a breadboard. I powered it with 5 AA batteries. It is 7.5 volts total. The Win input of Arduino should be powered between 7 and 12 volts. Here is the nRF24 transceiver module. I showed how I connected the cables on the schematic. Do not forget to use 3.3 volts for the nRF24. If you connect it to 5 volt, it may be damaged. The joystick has 3 outputs: vertical, horizontal, and the button. I didn't connect the button output because this project does not need it. Let's check the transmitter's code. We start by including the libraries that are required by the nRF24 module. Then we create the radio and define the address to which we are going to send the data. We define the joystick pins. Then create the array to store the data. We have 2 data, the vertical movement and the horizontal movement. We use these variables to set the interval between sending data. I have set it to 100 milliseconds. Then we start the radio and set it up. We set it as a transmitter by writing stop listening. In the loop, we have a prepare data function, which reads the joystick data from the analog pins, then writes the data to the array. After preparing the data, we wait at least 100 milliseconds, then send it. I do it not to confuse the receiver. Let's test it. On the serial monitor, the first value is back forward and the second value is left right. Currently, the joystick is at the center. If we move it forward, the first value goes up, and backward makes it go down. Moving to the left and right makes the second value down and up. This is the wiring schematic of my tank, also known as the receiver module. The nRF24 module is connected as it seems here. And the motor driver is connected as it seems here. My 7.4 volt battery is connected to the breadboard. It is time to assemble the tank. All the blue parts here are 3D printed. I will tell you later how to find them. There are also M3 and M2 screws, nuts and spacers. This is our rear chassis. The motor will be mounted here and the motor driver will be mounted on center. We will mount the motor here. I've designed the wheel for this motor. The motor shaft fits perfectly into its hole. First, I want to grease here because we don't use ball bearings and there will be friction. I've soldered the wires on the motor before, but I'm not going to show it because, believe me, you don't want to see me soldering. The rear chassis is ready. Now I must do the connections. I will mount the front chassis now. We have two unpowered wheels. They will be mounted on the front chassis. They will be held by the locks. First, I must screw the spacers. Now I will attach the suspension wheels. I didn't calibrate my 3D printer well and here is curved. I will use a gasket to make it more straight. I will mount my Arduino now. My Arduino has spacers because my battery will be below my Arduino. I will mount the breadboard now. It is time to connect the motor driver's data cables as it is shown in the wiring schematic. I'm powering my driver with 7.4 volts because there must be an additional 0.7 volts for each motor. Now connecting the nRF24. It is also shown in the wiring schematic. Placing the battery under my Arduino and screwing a spacer here to prevent the battery from moving here. Powering my Arduino with 7.4 volts using the Win input. This is the adapter connecting my battery to the breadboard. Track segments are also 3D printed. They can be attached to each other. There are 29 segments on each side. The tank is ready now. I'm placing it on a box for testing. I want to test the track directions because I'm not sure if I correctly connected the motor wires. It is my mistake that they are both red. I'm powering my remote control and my tank. Moving forward, You can see the right track is moving reverse. There are two possible ways to fix this issue. The first way is we can change the wire connections. The second way is to adjust its codes. I will fix it by adjusting the codes. Now we are in the tanks program. We include the libraries to use nRF24. We create the radio and the address variable, the same address we used in the transmitter. We create an array to store the received data. It must be the same size as the array sent by the transmitter. We will map the received data to the motor driver's requirements. There are also two variables called power right and the power left, which I use to steer the tank. We assign the data pins of our motor driver. Please note that the control pins must deliver a PWM signal. The connections are shown in the wiring schematic. Then we set its pins as outputs. We set the radio here. With the radio start listening code, we set it as a receiver. In the loop, first we have the get data function. We get the data when the data is available and we store it in the data received array. Then stop listening not to get confused. After that, in the process data function, we first map the received data. We got the vertical and horizontal movement data between 0 and 1023. We convert it to between -255 and +255. We use plus values to turn the motor forward and use the minus values to turn the motor backward. And same with left-right. Then we are setting the power right and the power left variables to steer the tank. While the joystick is on right, we cut the power of the right motor as much as the joystick is pushed, and the tank steers to right. When the joystick is in horizontal center, right motor runs with full power. When the joystick is full right, the right motor runs with 0 power, and other values in between. We do the same for steering left, and both motors are running equally while no horizontal joystick movement. This is how we power the motors. First, while it is going forward, then it is going backward. We use here the power right and power left variables to steer the tank while moving. When the tank is stationary, while turning right, the left track moves forward and the right track moves backward. And the same logic for turning left. Stationary turning speed is dependent on the joystick's horizontal position. While the joystick is on center, nothing works. I want to fix the issue with our right track. It was moving reverse. We can do it simply by changing the right motor's output voltage values, by making the highs low and the lows high. After processing the data, we start the listener which we have stopped after getting the data. I am uploading the corrected codes to the tank. Then I connect its power. The right track turns backward, because while we creating the data received array, we defined both values as 0. The program maps them both to -255. It means full back with full left. After we powered the remote control to, it sends the first signal to the tank and movement stops, because the joystick is in the center. Moving forward, moving backward, stationary right, stationary left, steering right while moving forward, and steering left while moving forward. Now it is ready to test on the ground. It looks great, but please don't forget that all of its parts are 3D printed. All moving parts are rubbing each other. Some grease or oil to its tracks may help a lot. I am planning to make a 3D printed remote control boat as my next project. I need your support to go on. Please subscribe to my channel if you want to see my projects. Also, hitting the like button or leaving a comment will help me a lot. You can get the digital material from my Patreon page. Thank you for watching.